One important concept for us to learn how to use matrices for solving linear systems is finding the reduced row echelon form of a given matrix, or REF in short. So what is REF? A matrix A of any size is in RREF if, number one, all zero rows, if any, are the last rows. So for example, if we have this matrix, this is not in REF because this matrix contains a 0 row, but it is not on the last row. Also, this matrix is not in REF. Although the last row consists entirely of 0, there is still a row of zeros wherein the row after that is not a 0 row. This one. For our second condition for REF, the leftmost non-zero entry must be 1. And this one, leftmost non-zero entry 1, is called the leading one of that row. So for this matrix, yes, the condition 1 holds. 0 rows are at the bottom. The leftmost non-zero entry of row 1 is 1. But the leftmost non-zero entry of row 2 is -4. The second condition is not met, so this matrix is not in REF. For our third condition, the leading one of ith row is to the left of the leading one of I plus 1th row. So for instance, we have this matrix. The leading one of the first row is to the left of the leading one of second row. However, this matrix is still not in REF because the leading one of the second row is to the right of the leading one in third row instead of to the left. Lastly, for columns with a leading one, all other entries must be 0. That is, the leading ones are the only non-zero entries in its column. So for example, in this matrix, rows 1, 2, and 3 have their leading ones, and their leading ones are on columns 1, 2, and 4. For column 1, this part, all other entries apart from the leading one are 0. So that is good for REF. Same with the second column. However, for the fourth column, there is a non-zero entry apart from the leading one. That is 4. Hence, this matrix is not in REF. If all of these 4 conditions hold in a matrix, then that matrix is in REF. We saw examples of matrices not in REF earlier. Now let's look at some examples of matrices in REF. So all zeros are the last zeros. Well, in the third matrix, there is no zero. There is no row which consists of entire zeros. But for this one, all the 0 rows are at the bottom part of the matrix. The second condition, the leftmost non-zero entry must be 1. So it holds here. The leftmost non-zero entry is 1. The third condition, the leading one of the ith row is to the left of the leading one of the I plus 1th row. So here, the leading one is to the left of the next leading one. Same as the second matrix and the third matrix. And for the last condition, for columns with a leading one, all other entries must be 0. And that is also true. Next, we will see that Every matrix can be put into REF by applying elementary row operations. So what are these ERO, or elementary row operations? An elementary row operation on a matrix A is any one of the following. The first type is when we interchange two rows of A. The second type is multiply a row by a real number that is not equal to 0. And the third type is when we add a multiple of a row to a different row. Let's have an example. Let us write A, this 3 by 5 matrix, in REF. Let us use the EROs, or elementary row operations, to write A in REF. What we can do here is the first type of ERO is type 1, wherein we interchange rows 1 and 2. Why is it so? Because the leftmost non-zero entry of row 1 must be to the left of row 2. So if we interchange this, row 2 here in A becomes the new row 1, and the row 1 becomes the new row 2. And so in this way, the leftmost non-zero entry, that is 2, is to the left, to that of row 2. But this entry must be a leading one. So what we can do here is multiply row 1 by 1/2. That is type 2. So here, we already write the rows 2 and 3 because we only want to change the row 1. Let us multiply it by 1/2. 0 will just still be 0. 2 now will be 1. Then follow the next entries, 3/2, 1, and -1/2. After that, we can add negative of row 1 to row 3. Why? Because so that the entries below this leading one are all 0. Remember that if a column contains a leading 1, then all the other entries must be 0. So this one should be 0. And for us to do this, add negative of the row 1 to our row 3. So what will happen is 0 minus 0, that is still 0. 1 minus 1, that is 0. 0 minus 3/2, we have -3/2, and follow the next entries. So we get this. 0, 0, -3/2, 0, and 5/2. Yep. After that, okay, so we can interchange rows 2 and 3. The first row is kind of okay. We will see later, but we will still change the first row later. But for the next rows, we have to interchange it. Because the leftmost non-zero entry, again, must be to the left of the next row. Of the non-zero entry of the next row. So interchange rows 2 and 3. This is the row 2 of the previous matrix. And the new row 2 is the row 3 of the previous matrix. The leftmost non-zero entry must be 1. So what we can do here is multiply row 2 by -2/3. If we do that, we have 0, 0, 1, 0, and -5/3. Yep. Okay, now that we have our leading one, let's go to our row 3 first. We can multiply the last row by 1/2 so that we get the leading one of our third row. If we multiply it by 1/2, we have 0, 0, 0, 1, and 1/2. Alright. All the conditions of REF are met except for the last one. The part where if a column has a leading 1, all other entries must be 0. So in this column, it has a leading 1, but the entry above it is not 0. So what we can do here is add negative 3/2 times this row to our row 1. What we mean is multiply the row 2 by negative 3/2 and add it to row 1. So for the first two entries, these are just zeros. So here we still have 0 and 1. But for this one, if we multiply this by negative 3/2 and add it to the 3/2 here, we will get 0. Here, this is just 0, so just copy 1, the previous entry. And for negative 5/3, if you multiply this by negative 3/2, you get positive 5/2. And add it to negative 1/2, you get 4/2, or simply 2. What else? This column. This column contains a leading 1 at the row 3, but not all entries are 0. The row 1 here must be changed, must be applied by a ERO. So what we can do here is add the negative row 3 to row 1. So multiply this row 3 by negative 1 and then add it to our row 1. So for the first 3 entries, these are just zeros. So we can copy the row 1, 0, 1, 0. But for the last two, so multiply this by negative 1. So we have here negative 1, then plus 1. We get here 0. And for our last entry, negative 1/2, add it to 2, we have 3/2. So if we check the conditions of REF, well, there are no 0 rows. So we don't have to check the first condition. For the second condition, the leftmost non-zero entry of each row are the leading ones. That's true here. The leading ones are to the left of the leading one of the next row. That is also true in this matrix. And finally, all other entries in the column with a leading one are zeros. Therefore, this matrix is the RREF of A. As an exercise, write this matrix in reduced row echelon form.